Welcome back to part 2 of arithmetic series and sequences. And if you'll notice from this example, I know I got cut off at the end of the last video, but let's just jump in and I'll show you what I mean by the 4 different parts. If I gave you this series, and you notice it's a series now because I've got plus signs in there, it's not just a sequence. 211 plus 193 plus 175, and the last term is negative 455. And if I take this series and I can figure out what D is, D between each one, and you notice it's decreasing, so if I subtract here, I'm going to find that the difference is negative 18. And I'm going to find here that this difference is also negative 18. That's good that they're the same. All right, so that's going to be my difference. I know that 211 is my first term. I know that negative 455 is my last term. I don't know how many terms I have, so I'm missing that. And I do need to know what that number is as to how many terms I have. I need to know that for the sum and to get the a sub n. Even though I already have that, I need to know what n is. And so I can calculate that with these 3 pieces of information. So I'm going to write that I need n first. And I'm going to calculate that by putting the a sub n formula number value negative 455 equals the first term, which was 211, plus n minus 1. I don't know n, so I have to leave it that way. And my d is negative 18. Okay, when I distribute that, still have negative 455. I'm going to have 211 distribute. I'm going to have a negative 18n, and I'm going to have a positive 18. I'm going to combine terms here. 211 plus 18 gives me 229. Yes, that's right, 229. I'm going to subtract that, put that on the left, which gives me a negative 684 equals my negative 18n. And that divides nicely so that my n is 38. I'm looking for the 38th term. So now I have n. Now I can go and I can find the sum. The sum then of the 38 terms is 38 divided by 2 times the sum of the first term, which was 211, and the last term, which is negative 455. Easily calculated, that sum, divide, and you will get a negative 4,636. Much easier than sitting there and calculating all of this sequence until you get to that term, all 38 terms you know now, and then adding them up. This was much faster. So we like these formulas. Okay, let's look at another one. Remember, when we can write the sum, we can write it with sigma notation. Now this one's a little easier in that it's a little bit more concise. Scoot that up a little bit. Remember, this is the lower bound and the upper bound, and there is the equation. You are trying to find the first term and the last term to get this sum. Now I'm going to work this as if I don't have a calculator and I'm working it out with this formula. So I need the first term and the last term. So the first term would be a sub 23. I evaluate this at 23. So I've got 2 times 23 plus 3, which would give me 46 plus 3 is 49. Okay, then I could evaluate the last term, which would be a at 37. Again, 2 times 37 plus 3, and that value is 77. So I know that I have the first term and the last term. Now you can calculate how many n's you have, how many terms you have between these two. If you take the upper bound minus the lower bound and then add 1, that will give you your n. Let me write that down. So to get the n, you're going to take the upper bound minus the lower bound and you're going to add 1. So I have 37 minus 23 plus 1, and I know that I have 15 terms. So our 15 is my n. Now I can go ahead and plug that in the sum formula. Let me scoot that over here, and I'm just going to do it right here on the side. That sum formula would be the sum of 15 terms would be 15 divided by 2 of the first term, which was 49, and the last term we calculated as 77. Evaluate, and you get 945. Now there is a way to evaluate this in the calculator. Your calculator has a tool that has a summation in there. If you'll select the math command, and I believe you go down to 0, and it says summation. And you put in the index as a variable, could be any variable. You put in the lower bound and the upper bound, and then you put in the function, and it will magically come up with 945. I would encourage you to still know how to do this on the assessment. You're still going to need to show us this formula, and if you want to use the calculator to check your work, I think that's fine. But don't lose sight of being able to use the formula without the calculator. So this particular lesson, we've been talking about the common difference, and where you just subtract the first two numbers and you get the difference and you use those wonderful formulas. I do want to take a moment to talk about some other common differences. And this is kind of cool because anytime you have just a series of data in numbers of a sequence, you can determine sometimes what type of equation that is. Sometimes without even using a calculator. Sometimes we tend to just put data in and look to see what the graph is and get the line of best fit and all that fun stuff. But there is a way to algebraically do that, and I'd like to talk about that. So you can get other common differences. Now let's look at this particular sequence. If I go from 13 to 8, that is a difference of 5. If I go from 20 to 13, that's 7. Well, that's not the same. That one's obviously 9. This one's 11. All right, I see a pattern here, and that's 13. Well, that didn't really help me at all. All right, that is what we call the first difference, because it's the first difference. There we go. Difference that we did between the values. Well, let's try to get it again. Let's try subtracting again. If I do that again, oh, look at that. That's 2 and 2 and 2 and 2. So that means our second difference was all the same. When you get to the difference that is all the same, that indicates what type of series that is, and that indicates that this would be a quadratic. Right? Most equations to the second degree are quadratic. That'll help you remember it. It has nothing to do with these twos. But the second difference is quadratic. Now the first one, remember, with our arithmetic, if that had all been the same, just like we've been doing for the rest of the earlier in the lesson, that would have been linear, right? Because the difference, the common difference was the d, the slope. And so if you have a linear equation, and I'm going to go ahead and write down some of those functions, we determined that was a sub n is a sub 1 plus n minus 1 times d. You can also write that, and you'll see that a sub n as the difference times n, and we ended up simplifying one of those equations to get that, plus the constant. First term. Now if you have a quadratic, you're going to have the form, the nth term would be our normal quadratic formula, would be a n squared plus b n plus c. So you need to use the series somehow to calculate the a, the b, and the c. And this is remarkably easy. But before we go ahead and do that, and we're going to do that on an example, I do want to talk about some of the other differences. So you can guess what you think the third difference would be. Let me, let's see, I'm going to write that here. The third difference would be cubic. And its equation is very similar to this. The nth term would be an to the third plus bn squared plus cn plus d. So here you would need to find those four values. Now if I have the fourth difference, oops, I got my D's and my F's mixed up. Difference there. This one, do you remember the word quartic? And the fifth difference was quintic. Remember those from earlier in the year? And those equations follow as well. So you can determine the other equations. In our lesson, we aren't going to go any beyond, I don't believe, the quadratics. That's the example I'd like to do right now. If you want to find the quadratic model for the following series. Now, well, it's a sequence right now, but we're going to find the quadratic model for that sequence. So first, you'll notice that this is the first term, this is the second term, this is the third term, this is the fourth term, etc. And you're going to use this formula right here and set up those equations. So when I do that, the first term, the negative 14, is equal to a, and the n, if I'm doing the first term, the n is 1, plus b times the n, which is 1, plus c. Now the second term is negative 8, and I have a times the n, which here is 2. b times 2 plus c. The third term is 0. So I have a times the third term squared plus b times 3 plus c. Now I'm going to stop there because I have 3 variables I need. I have 3 equations, and that's all I need to do. If I was doing the cubic and I needed 4, I would make a 4th equation. I would go to the 4th term. But I'm going to stop there, and now I'm going to simplify this. And I'm going to say negative 14 is a plus b plus c. And negative 8 is going to be 4a plus 2b plus c. And 0 equals 9a plus 3b plus c. Now if you recognize this, you have a system of 3 equations and 3 variables. And now I'm going to use matrices to solve this. Now we haven't covered matrices specifically. We do that in Chapter 6, and we will eventually, but we haven't done that yet. So very quickly, and we may finish this in class, but because I look like I'm about to run out of time, but I do want to set up the matrix really, very quickly. Here you take these coefficients. So I've got 1, 4, 9. I've got 1, 2, 3, and I've got 1, 1, 1. And then you put these values on the end. And 0. You're going to go to the matrix. You're going to say that this is 3 rows by 4 columns, so you have a 3 by 4. You go into edit, right, and you put in a 3 by 4. You put in the values for the matrix. You then you go back to matrix and you select the math part, and then you select RR. In math, you're going to, I forget what the number is, but it's RREF is the one you're going to select. Then you go back out into matrix and you have to select the matrix that you have put in to be that particular matrix, and then you hit enter. And it will give you a matrix that will have 1, 1, 1 here in the diagonal. Everything else is zeros, but this last column will be your answers. And it will tell you that A is going to equal 1, B equals 3, and C equals negative 18. And you can write your equation that way. All right, I will see you in class when we get to work these together. Thank you.